Welcome back, Mrs. Boots again. We have our next parent function, cube root. This sounds similar to something else. We had another root, square root, right? Square root was the inverse of which function? Oh yeah, you got it, quadratic. So cube root would be the inverse of? Very good, cubic, okay? So we don't have specific examples for our cube root, but we know if we were to work backwards from our cubics, we would get a cube root. So they're very, very related in the real world. So our parent function, this is the one that freaks everybody out. So I still have a radical with an x, but to indicate cube root, I put a little 3 right out front. That little baby 3 tells me it's a cube root and not a square root. Okay? So cube root, remember square root, I say what squared gives me this number? Cube root is what cubed gives me this number. The cool part is it's backwards from the cubic table, okay? Because remember inverses, we're going to switch the x and y's. So if I look at my table, the x values for a cube root are the same as what? You got it. The y values for the cubic. So my y values should be same as what? The x values for the cubic. So the cube root of -8 is -2. -2 cubed gave me the -8. Cube root of -1 is -1. If you don't believe me, plug it in the calculator. That's okay. You don't have to take my word for it. 0. Guess what? It's a 0. 0, 0. Okay, 1. Cube root of 1, 1. Cube root of 8, 2. Easy enough. Now let's take those and put them on the graph. Okay, so yeah, I know, -8 is so off my graph, but that's okay. So we're going to go -8 all the way over and then down 2. So I'm just going to put a little reference point right there on the edge of my graph. I know it goes a little further, but I think we can handle it. -1, -1, 1, 1. Oh, missed it. Sorry, skipped it. 0, 0. Still there. And then 8, 2. Again, off my graph. Okay? And you're thinking, well, it kind of looks like a crooked linear. It is. Okay? So it looks like I took my cube and turned it. I just turned it. Okay? So it looks similar to the cubic laying down on its side. It's taking a nap. Okay? So my cubic and my cube root both have the S shape. It's just the cube goes up and down and the cube root lays down on its side. So now let's do our domain and range. Domain. Easy enough. Guess where it's going? -infinity. So simple. And all the way to the right, just like Buzz Lightyear, +infinity. Super easy. The range, how low does it go? Well, you might be saying, Mrs. Boots, it's kind of stopping about -3 down there. Nope. Remember that quadratic? It went up and up and up, but it also went out. Well, our cubes and our cube roots also go both ways. So as it's going to the right, guess what? It goes further down. So further down means -infinity. It's kind of slow about it, but it's lazy. It's taking a nap, so it's okay. -infinity. How high does it go? Yeah, it's going to go to +infinity. It's okay if it doesn't get there as fast. It's still going there. It's just going a little slower. So my domain and range are the same again. That's awesome. Same domain and range. And they're infinities, +infinity, -infinity. Which other parent functions have the exact same domain and range? Positive, -infinity. You got it. Linear has it, and cubic. Both of them have -infinity, +infinity for the domain and for the range. So it keeps going in all directions. Now we're going to explore. We have 3 parent functions left, and they're the tricky ones. So pay attention. We'll get to them in a second.